Hello and welcome to a new video lecture. In this lecture we are going to talk more about the bits, the bytes, and the word. We are going to discuss how to perform bit logical operations on them. So let's get started with a quick refresher on binary operations. In Arduino we can define a variable to be of the type byte holding 8 bits, and each one of them can be a binary value, either 0 or 1. By defining a variable we say byte, that's the type of the variable, x, that's the name of the variable, equals, and then we assign the value. When we type capital B letter, B for book, then we can define a binary value. Here we are defining 8 bits, 1101 0001. And then we are defining another variable, binary variable, to be B0001 1101. So we can perform a logical AND operation which takes if both values assigned bit are both 1, then the result will be 1. If either of them or both are 0, then the result will be 0. This is quite useful in masking out some bit values and handling some pins of the Arduino board and other microcontrollers as well. So for example, if we start by applying the logical AND operator to both x and y, we get a binary value 0001 0001. So if you walk it one by one, you find that every significant bit where both values are 1, we got 1, otherwise we get 0. And then if we apply the logical OR operator, we find that we get more 1s, since if either or both of the values are 1, then we get 1. If both are exclusively 0, then we get 0. More interesting, if we apply the exclusive OR operator, then we are only going to get ones where both bits are different. Either one is 1 and the other is 0, or one is 0 and the other is 1. So we get different value, 1100, 1100. That was very nice, but working with binary values is not always very efficient, so people have come up with the hexadecimal representation, and that's what one usually works with. So we represent the values with base 16 numbers, so we start from 0 up to F, and then you can see that we represent every 4 bits with 1 letter, which is more compact representation of the values, and you can see it's much easier to understand. So our x is D1, our y is 1D, then if we apply the AND operator we get 1 1, and if we apply the OR operator both become D, and the exclusive OR we get CC. It's interesting to know that the hexadecimal representation in Arduino is represented using 0x as a prefix to every value you are going to assign. So enough theory, let's get into practice. So let's start a fresh Arduino sketch, an empty one, and let's play around with the concept. By now you have become an expert on how to include the serial software, #include software serial.h, then Ctrl S to save, you assign a name to the sketch, press enter, now it is saved. Serial.begin 9600. Now let's use the setup so that we don't get much repetition of the values. Let's define a byte, x equal 0x1101 001, and byte y equals 0x001 111101. And then let's print the output, serial.println logical and serial.println x and y. And let's check the output. First upload to the Arduino board, make sure that it is connected to the USB port. I'm missing a semicolon somewhere. Yes, over here and over there. Oh, missing another colon or semicolon. Can you guess where it is? Oh, okay, so you see it doesn't support spaces in between. And here we go. So let's clear the output and reset the Arduino, and that's what we get for the logical AND. We get simply the number 1. So you can see that it has converted all the ones to zeros. I believe, oh, can you figure out what went wrong in this example? Because here we have the 0x, that should be a B, right? Sometimes like this, because one usually works with the hexadecimal, but sometimes you have to work with the binary as well. And here we get 17, and if you convert 17 to binary, you find out that it is 001 and 001 again. So interesting, now we know how to perform that operation, and you can try out with the different operators like the OR, or the exclusive OR, and so on. Let's bring it back to AND. So let's try something even more interesting. So let's play with the hexadecimal. You already know by now that this is also possible in hexadecimal. 0xD1 0x1d. Let's save, upload, and check the serial monitor. We've got the same result consistently, and so on. So now that you have mastered this operation, let's get out something more interesting. So now we know the byte is 8 bits. Or if we need more capacity or higher value, what we usually would work with is the word. So let's say that we've got a word that's 16 bits. And another word y 16 bits. So that will give us double the range. So we can say here D1 and 1D. And let's see what we are going to get. Uploading, serial monitor. And we are getting a much higher value. So words are basically 16 bits. So you need to be aware of these conventions when working. Most of the time you find that you are getting issues just because you forgot to flip a bit or forgot to wait for a wake up signal on some port and so on. So now that we have done that, let's do something quite interesting with the logical operations, which is the shift operator. So let's define a global variable, word1 equal 0x and 1, and another word maximum or full, which equals 0x f. Now let's remove this part or just leave it commented. You can actually comment a block of code by clicking on the keyboard, typing Ctrl and /. And then over here we say 1 shift left equals 2, which is a shorthand for saying that 1 equals 1 and then the operation like plus equal minus equal. But you can do that also with bit operations. So 1 left shift operator by 2 and then serial.println 1. And let's give it some delay so that we can observe the changes. Let's make a delay of 2 seconds. Well, let's upload and let's see the values. So let's reset so that we can catch it from the beginning. Now that I have reset the board, you can see that we're starting with 1 shifted left twice, 4, 16, 64, 25, 6, and it goes on. So the shift left operator, and then it accumulates. When it has reached the end, it becomes a 0. So the shift left operator, it shifts the bits 1 position to the left. That's equivalent to power of 2, because every bit in the bit string is a position 2 power 0, and the next 2 power 1, and the next 2 power 2, and so on. So if you have a bit with the value 1, and then you keep on shifting that bit along the string, you'll be as if you are multiplying it by 2 power 1, 2 power 2, and so on. So that's interesting. Let's reverse the operation. Let's say here full, and then instead of the left shift operator, let's make it the right shift operator, and instead of printing 1, let's print full. And let's not forget the serial monitor. So here we started with a higher value, and then we keep on dividing. So the left shift is multiplying, the right shift is dividing, and it will become 0 very soon. And now it has become 0. So that's it. Let's do something quite interesting. Let's say, for example, that we have got the port in one variable, and we want to set only 1 bit of that port to be 1, or a couple of bits. But let's start with 1 bit for simplicity. So let's copy over the code so that you can use it later. And let's create a new file over here. And let's remove these parts and remove these parts. Now let's define an arbitrary word variable. So here we've got our 1, and here we've got our full. So let's work with that. So let's apply a masking over the 1 operator with the full operator. So we say that word output equals the full variable and the 1 variable, and then serial.println out. So since it doesn't really print in binary hexadecimal, and you need to do some formatting on your own and utility functions to print the actual binary and hexadecimal values to the serial. But let's see what it gives. Let's Ctrl S and save. Let's say that video 5 number 2, and let's upload it to the Arduino board and check our serial monitor. So that gives us 1. Since we have got the 1 bit the endmost position, the rightmost position, let's do something interesting by saying we want here that we're not interested in the first position, but we are interested in, let's do that in binary actually. So let's say that we are only interested in this bit and we are not interested in anything else. So we have to type in actually 16 times. So far we have got 8, 1, 2, 3, 4, 5, 6, 7, 8. And let's see how does that compile. Can you guess what went wrong? So we've got here 4, we've got here another 4, that makes this 8. Oh, I've got here another 4 and another 4. So let's move that part inside the setup. Let's try again. So that wasn't it. So apparently you can't do that with the word variable or data type. If we fall back to the byte, let's do that quickly. We fall back to bytes, and then we just cut another 8 bytes from here, and we cut 8 bytes from here, and let's try again. Now it has compiled, so one always get tricked by this difference of types. Now I've got the ending, which is a different value 32, that means the position 5. So the bit at position 5 is set to 1. Why is this interesting? This is interesting because sometimes you have over a port or register of 8 pins, and then you only want to get the input on one of these pins and manipulate the value, or sometimes the sensor, they will send a control signal or a start signal before they send the actual data, and you have to do this kind of manipulation by your hand. Now you've got a feeling of how this works in Arduino. You have tried the bits, the bytes, the words. You have tried the logical operators, the AND, the OR, and the exclusive OR. And you have also tried the operators, the shift left and the shift right. Thank you, and see you in the next video.